and welcome back. In this video, we're going to discuss physical quantities. And these physical quantities in physics just talk about the properties of materials for which we use in measuring or quantifying any materials. Quantifying means measure. So this physical quantity has two types. The first one we're going to talk about is the fundamental quantity, and the second one is a derived quantity. So fundamental quantity is the quantity that does not depend on any other quantity. In this case, the quantities that comes under this, they come in natural. They don't depend on any other existing quantity. They exist on their own or by themselves. So that's what we call fundamental quantity. So when you think of fundamental quantity, think of those quantities that exist by themselves, that they don't depend on any other quantity. So that's why we define fundamental quantity as those quantities that are independent of any other quantity. Or you can define it as those quantities that does not depend on the existing quantity or any other quantity, so to say. So that is what fundamental quantity is all about. We have three basic fundamental quantities. In exam setting, they may ask you, what are the three basic fundamental quantities? What you should tell them is, firstly, tell them time. You also consider length. I'm not showing the orders for which they are arranged, and then mass. So I would like also to show you the unit for which these quantities are measured. Time is measured in seconds, and then length is in meters, and mass is in kilogram. The short way of writing this is, or symbol for this is S, here is M, and here is K. Right? We use this kg as kilogram for mass. So these are the basic fundamental quantity. That does not mean they are the only fundamental quantity that exists. We still have other ones which include thermodynamic temperature. We can simply put it as temperature. And this temperature is measured in Kelvin, which the symbol is just K. Another one we're going to consider is amount of substance. This amount of substance is measured in mole, and we use MOL as the symbol for mole. And then the next one we have is luminous intensity. Luminous intensity is measured in candela. And then we use C subscript D to represent candela. So we have listed 1, 2, 3, 4, 5, and 6 fundamental quantities. That does not mean these are the only fundamental quantities we have. We still have the one we call the electric current. And electric current is measured in ampere, which the symbol is A. I will just leave it with this. I'll leave you with this basic fundamental quantity. I've shown you that these three are the basic, and the rest of it, in fact, all of them are all fundamental quantity. But these three are the basic fundamental quantity. We want to talk about dimension and dimension analysis. We will use these three in order for us to be able to work on the derived quantity. So if we've understood the concept of fundamental quantity, the SI unit, which is the international standard unit, which is SI, standard international unit, SI unit, that we use in measuring this quantity, and then also the symbols for which they are represented, then let's move on to the next one, which is the derived quantity. So firstly, what is derived quantity? Unlike we mentioned that fundamental quantity are those quantities that does not depend or that are independent of any other quantity, in the same way, derived quantity Or some case you can use quantities, the same way the other one could be quantities. In the same way, derived quantities are those quantities that depends on the already existed quantity. So that is to say, the derived quantity depend on this fundamental quantity. So you can see the two definitions. They are very simple. Fundamental and derived quantity. One is independent, one depends. So let's see the examples of derived quantity. The following are the examples of derived quantity. We can think of the first one, which is velocity. Velocity is a derived quantity because it comprises of the quantities we have in the fundamental. For example, you know, of course, that velocity talks about displacement, the displacement or distance. Whichever one you can use is still the same. They are interchangeable, displacement and distance. All right. This is a formula for velocity. The formula comprises of both the fundamental quantities. Distance is a fundamental quantity. Time is also a fundamental quantity. Of course, distance is the same thing as length, which is measured in meters, and time is measured in seconds, like we discussed. And then the formula becomes meter per second. That is the unit. The unit becomes meter per second. That is for velocity. You can see meters and seconds. They are the properties we've mentioned under fundamental quantity. So that is why this is derived, because it depends on the fundamental quantity. All right. So the next one we want to talk about is force. Force is the product of mass times acceleration. Okay, these cases, or in this case, mass is measured in kilogram, and acceleration has its formula also. Of course, you know that mass is the property of the fundamental quantity. Acceleration talks about the change in velocity with respect to time. If it talks about the change in velocity, the initial velocity and the final velocity, or in simple case, you can just put it as a change in velocity with respect to time. And of course, you know that velocity is talking about distance over time. You can see how we are breaking it down. So if velocity, in each case, we have this unit as meter per second, and time is also in seconds. So we have meter per second divided by second. And this will give meter per second squared. Or some cases you can write it as this, meter per second squared. So if this mass multiplies by this, so we have the unit of force to be kilogram meter per second squared. Now check all the quantity we have here. This is for mass, this is meters for length or distance, this is S for time. And all these things are coming from the fundamental quantity. So you can see how this is a derived quantity. Other quantity also that we'll mention is momentum. So what is momentum? Momentum talks about the product of mass times velocity. So if momentum is mass times velocity, with the symbol for momentum, linear momentum, we use P to represent. If it is angular momentum, we use L to symbolize it. But for this, P is equal to mv, which is mass times velocity. Mass is also measured in kilogram. Velocity is meter per second. Meter per second, right? All right, you can see that all the quantities here are fundamental quantities. All of them combines to give what we call the derived quantity. I hope this makes sense to you. I hope you're enjoying what fundamental quantity and derived quantity is all about. We can be able to do as much as we can, as lengthy or a lot of this quantity, because there are many. So if you can remember any of the derived quantity and try to fix it, or maybe you have challenges in fixing what the unit or the formula could be, then you can also drop the question in the comment section. I'm going to respond to you. I'm very active to respond to you at any point in time. But this video just explained the concept of fundamental and derived quantity. The next video, I'm going to teach what dimension and dimensional analysis is all about. So please make sure you subscribe to my channel and also turn on the notification bell, and make sure that if you see the next video, it might be for the next video that I have promised to do, which is on dimension and dimension analysis. You will now see how this physical quantity, which involves fundamental and derived quantity, can be manipulated in order for us to get some unique functions. Thank you very much, and see you in the next video. Peace.